Welcome to Bouncy Learning Videos. Today our class will be on power and product rule and differentiation. So power and product rule are all in differentiation. So our first one, representation. So let's say this is it. So we have f of s to be this. When we are told to differentiate based on the power rule, you are going to get the exponent will come down to multiply the function. Then you subtract 1 from the exponent. So this is how power rule works. So I'm going to give some examples. So let's solve them together. We have x to the power 5 and y to the power 8. So for the x to the power 5, we are going to get 5 multiplying s to the power 5 minus 1, which is the same as 5s to the power 4. And the second one, y to the power 8. 8 multiplies the whole function. Then you subtract 1 from the exponent. We are going to get 8 y to the power 7. Another representation. So we have two functions which are different. So f of s times g of y. So these are functions. So if you are told to find the differential of this, we are going to get the differential of f of x times g of y plus the differential of g of y times f of x. So it looks like f of x and g of y, and they are differentiated ones, they alternate. So f of x times g of y. So here f of x is differentiated plus g of y also differentiated times u. You can see that x and y are different. The second one is 5m to the power 3 times n. M and n are different. Then the last one, a times b squared times c squared. So a is different from b, different from c. Alright, so we are going to solve it. So we are solving the first one. So you can represent f of s to be s squared. Then g of y to be y to the power 3. From this formula that I gave you in the previous slides, this is the same as f of x, which is differentiated times g of y plus g of y differentiated times f of x. So with the same approach, x squared will be differentiated times y cubed plus y cubed will be differentiated times s squared. So when you differentiate s to the power 2, so when you differentiate s to the power 2 from the power rule, you're going to get 2s to the power 1 times y3 plus. Then for here, you differentiate y to the power 3 from the power rule. 3 to the power y2 times s squared. So here you're going to get 2x y3 plus 3y squared x squared. So for the second one, we are going to use the same method, and 5 is a constant. So this is what we are going to get. 5 will multiply the whole. M to the power 3 will be differentiated, which is 3 times m to the power 2 times n, plus, here n will be differentiated. When you differentiate n is to the power 1. So 1 times n, 1 minus 1. Any number raised to the power 0 is 1. So the answer is 1. So n differentiated will be 1 times m to the power 3. So here we're going to get 15m squared n plus 5m3. This will be the final answer. So for the last one, with the same approach, here we can see that we have 3 different variables we do not know. So they are distant, they are different from each other. That's how we're going to do. First of all, you take one of them. So a will be differentiated times the rest, plus b squared will be differentiated times the rest, plus c squared will be differentiated times the rest. So this is how you're going to go by it. So in case it was 4, you get 4 parameters. So for this one, you're going to get 1. Yeah, I've already talked about it in the previous slide. So you're going to get b squared times c squared, plus differentiate b squared from the power rule, you're going to get 2b ac squared, plus differentiating c squared same as the b squared, you're going to get 2c ab squared. So this is how you're going to differentiate